Again, it's great to see you guys. You guys look amazing. Okay, as I have probably already told you, my name is Kevin Jones. I am a developer relations engineer. So what does that mean exactly? Well, I work with developers that are building on Web3, and I help them, learn how to build, learn how to create solutions that make sense, and more importantly, at the Graph, I deal a lot with data, right? Helping people organize their blockchain data and make it easily consumable in their applications. So that's what I'm going to talk about today. So I think we've kind of talked a lot about the DApp architecture. So we have this concept of a decentralized application, right? You have a front-end application that is HTML, CSS, JavaScript, all the static assets, right? And this is kind of the initial design as you deploy that static application. And then you have your business logic or your smart contract that lives on the blockchain, right? And this is great, but when it comes to reading data from the blockchain, reading data from Ethereum is free, right? You can do a JSON RPC to get the current value of a variable, right? You pay for security, update the state of the variable, right? To update that variable. Or to update anything in the smart contract. But for reading, it's free. So the nodes are not really incentivized to serve, I guess, quick and reliable amounts of data. And so there is this issue where it is a little bit slow and it's cumbersome, like the JSON RPC is not really optimized for reading data. Actually, the JSON RPC endpoint was originally created to manage an Ethereum node and not really to query. So what we see is something like this in the wild. This is actually real code at a hackathon, where someone wanted to get all of the NFTs in a particular wallet. So all they needed to know is how many NFTs did that user have when they connected their wallet. So you have to do this thing where you create an object, you get the balance of the actual wallet, then you have to loop through that balance and get all of the token IDs and then push those into an object and then display those as a result, right? Using the return. And this is okay if you only have like 2 or 3 NFTs, but if you have hundreds of NFTs or thousands of NFTs, which believe me, there are people like that, this could easily take minutes to load a web page because it's having to go through and build this object. And every time it does that, it's doing a call, an ETH call, a JSON call, JSON RPC call. And so this is just unreliable, right? So what we actually want to do is index the data, right? We need to find a way that we can index the data and make it highly available. And so the general method to do that is called the ETLQ, right? So you take the data, this applies to all data, I guess, data science and data analytics, is you want to extract the data. You probably want to transform the data in a way that makes sense for you to actually consume it later. Load it into some kind of database or some kind of object, and then make it queryable so it's easily accessible, right? So if we think about an Ethereum block, like every single 10 seconds, there's a block. Inside of that, there's hundreds of transactions. There's people are sending ETH across from each other. People are calling functions. They're updating state, whatever. There's a lot going on, and there's a lot of different protocols that are emitting these events, right? We talked about events earlier. We created a few and emitted those, and you know what those look like. So it's a kind of a mess. It's kind of a sea of craziness. So what we want to do is take those events. So a smart contract emits an events, and then we want to store those somewhere, right? In some kind of database or some kind of consumable way. So what is the graph? Well, the graph is a solution, or one of the solutions to this problem. It is essentially the data layer of Web3. So we are a decentralized network of nodes. So similar to how Ethereum has a decentralized ethos to it, so does the graph. All of these nodes are running indexers. They're called indexers. And this is what you actually see live in the in footage of what it looks like. So I don't know how this works, but if anyone can tell me, that would be great. I feel like this is somehow rigged, but anyways, this is what the graph does, is it organizes all those crazy mess of transactions into buckets that we call subgraphs, okay? So we take that initial architecture where we have the app that sits on the front, the front end. We have the blockchain, the smart contract. It's still incentivized for the security of the network, but we implement this middle layer, right? This middleware layer, and that is called the graph, right? So what we can do, I don't know what's up with the load time on this, but there we go. The graph is built, and I'm going to dive into this a little deeper, but it uses what's called GraphQL. Show of hands, who here has used GraphQL? A few of you, okay. So it makes sense to talk about it then. The cool thing about GraphQL is it is called a query language, graph query language. So it allows you to do a query, pass in variables or data that you want, and then get exactly the structure that you want. So like if you wanted to eliminate the token ID or the metadata or whatever it is, you can customize the query, and that will optimize the data response that you get back, right? So this is very, very useful for front-end developers, particularly because you can do a GraphQL query against your data. And with that same kind of code I showed earlier, we can just do one single HTTP query against the GraphQL endpoint to get all of the data we care about. So no looping, no building objects, just a single query. So again, we have the network participants. This number changes, but you can say there's at least 200 indexers running on the network that are indexing data. And there's also people that are just involved in the protocol, maybe even some of you guys that have staked some GRT. You can do staking, like similar you can with Ethereum. You can also curate subgraphs. So if there's DeFi protocols that you think are very popular, you can go on there and find those things and then add some stake there. You can also deploy your own subgraph if you're a developer, and you can get paid for the queries fees that go through that. So there's a lot of ways you can interact with the graph. And so in the end, I think the goal is to build truly decentralized apps. And in order to do the data in a truly decentralized way, you need something like the graph, which is a decentralized network. So here we have the same ETL queue that I talked about. So we, in this case, Ethereum, all of the events are available over JSON RPC. So we extract them using just a standard JSON RPC call. We transform those using a processing engine called a WASM. WASM is basically a WebAssembly. And we use assembly script, which is very similar to TypeScript. So if you've kind of used TypeScript before, assembly script is very different. It's a little bit, it looks exactly the same, but it has a little bit less features than TypeScript. And you can process the data or transform it however you want. And then you load it into a database. So the graph is built on Postgres. So we have all of the indexers run Postgres, and that's where they store all of the data for the subgraph. And then that's exposed using GraphQL, right? And the beautiful thing about this implementation is it is open source. We use Postgres, which is open source. We have GraphNode, which is all open source. And we use IPFS, which is the interplanetary file system, which we didn't really talk about that today, but it also is a very important part of decentralization. But we use all of those three things, so it's a completely open source and anyone can be involved. You can even run your own indexer. You don't even have to be a part of the network. You can just run it yourself. So this is kind of what it looks like at a high level. So imagine you have your dApp, right? HTML, CSS, JavaScript. You still deploy your smart contract on the Ethereum chain of your choice. You still propose transactions and make transactions to your smart contract. But in this case, your smart contract emits those events. Those events are picked up by what's called GraphNode, which is the open source engine that essentially does the processing of the data. You can think of it as kind of like similar to the EVM, but it runs a Rust program that is isolated and protected. So it runs that data. It does what's called mappings inside the WebAssembly, and it stores those in Postgres. And then it provides a GraphQL API for your data. So that same sea of mess that you see gets kind of consolidated into something like this, where there's have these unique buckets that you can actually go to and then get the data you care about. So if you care about, you're into DeFi, you want to look at Uniswap, which is our like most used subgraph, you can go on there and see all of the swaps that happen. You can see the TVL. There's all sorts of calculations that are in there. We have Aave. If you're into NFTs, we have Foundation, MakerDAO, Zora, whatever it is. You can search on the Graph website. So if you go to thegraph.com/explorer, any kind of Web3 protocols available on there. And if there's not one, you can build one, and then you can get incentivized to store that data or to do that. This is very useful if you guys are at all interested in what we did today, and you guys were very interested in the speedrun challenge. I also did a full stack workshop. We have a special branch of Scaffold ETH that comes with the graph integration. It's called the subgraph package. And this URL will take you, if you just go to bit.ly/fullstackdApp, or if you scan this, it will take you to the GitHub. And then inside the GitHub, there's a video. So you can watch the video. It's about an hour and a half long. I go through the workshop and teach you about Scaffold ETH, and I teach you about the graph and all that stuff that I just talked about in much more detail. I think I just want to show really quickly the graph website. So if you go to thegraph.com and you kind of take a look, when you first go there, there's a few different things you can do. If you're a developer and you want to create customized subgraphs, you can go to the Subgraph Studio. If you are a developer and you just want to get access to existing data that's already available, right, then you go to the Explorer. So as an example would be, like, let's say you wanted to know about, who here, raise your hand if you've heard of CryptoPunks. CryptoPunks, no? Little guys with mohawks and glasses, no? No one's seen those? Overpriced JPEGs. So if you, let's just give you an example. Let's say you did a CryptoPunks, do a search. You can find all the subgraphs for CryptoPunks that are available. So if I want to grab this one, I can click it. Those are CryptoPunks, by the way. And you can come and see that this data is indexing. It's 100%. And you can see who's indexing it. These are all the indexers on the network that have indexed it. These are all decentralized indexers. And you can also see who's curating on it. But more importantly, you have this playground. And here you can say, okay, well, what do I care about? Well, let's say I want to get all of the punks, their ADs, who owns them, etc. I can just hit play, and it gives me all the data back in this easy to consume GraphQL API. So this is really cool because you can just plug this in to Python. You can plug it into whatever, whatever programming language you want. You can do a query. There's a lot of like GraphQL SDKs and ways that you can interact with that. There's also some Python tooling, JavaScript, you name it. There's tons of ways to get that data, and you can make a query, get that data back, and do whatever you want with it, right? So whether it's building a front end for some kind of DeFi protocol, or maybe it's you want to do some like AI stuff, maybe you want to do some machine learning on it, you can get that data, and it's available. Okay, so yeah, if you guys want to get started, the best way to do that is to go to the docs. So anyone who wants to learn more about the graph, go to the docs, and there is a section called the Quick Start, which is, there's some stuff about the graph, how it works, but I think right here, the Quick Start, especially if you're a developer, is kind of the best starting point. So you click that, and it will kind of walk you through. But if you just want to, in general, learn about the graph, there's tons of resources here in the docs. It's not loading right now, but if you go to thegraph.com, everything you need is there. Yeah, I'll give like 5 minutes for questions. Have questions at all? No questions? 1, 2, 3. Oh, I see a hand up there. All right. Yes. Yes. I always pull at least one question out of the crowd.
Yeah. So, what is the difference between the graph and traditional block explorers? Yeah.
Great question. So the difference between the graph and traditional block explorers. So traditional block explorers usually have centralized infrastructure. None of them actually, that I know of, use the graph. Maybe some of them do, but for the most part, they're probably storing data in their own like centralized solution. So I would say they're a little bit less trustworthy in that sense. Whereas something like the graph is, we have, let's just say for this example I just showed was a CryptoPunks, and there's like 15 indexers. You can kind of guarantee that the data that is on those indexers is probably 100% correct, because if one of those indexers operates in a malicious way, they'll get their stake slashed. So it's in the best interest of serving accurate data. Whereas something like a block explorer could easily be hacked to manipulate the price, let's say, of a token, and show that a token maybe is worth more. And if someone is using that as a source of the price, that could be a security problem. So that's the main difference, is you're using a decentralized network which has a consensus and proof of whatever you want to call it, proof of data, versus something that's centralized that you don't really have a way to verify. Yeah, hope that helps.
Yeah. Okay. Good. Thanks.
Yeah. Good question.
Yeah.
Any other questions? Awesome. You guys are amazing. Thank you so much. Love you guys.
Thank you so much, Kevin, for all your talks today and more